Good evening, class. We are looking at pre-calculus practice test number 5. Module 5 covers chapters 9, 10, 11. And here's chapter 10, analytic geometry. Find an equation of a circle with the center at 1, -2 and radius 2. Also graph the circle. So first and foremost, what is a circle? A circle is the set of points in a plane that are the same distance called the radius from a fixed point called the center. Therefore, if the center is located at 0, 0, it has the equation x squared plus y squared equals r squared. If it's located at a different location such as h and k, the equation is x minus h quantity squared plus y minus k quantity squared equals r squared. And it comes from the distance formula, where distance formula itself comes from Pythagorean theorem. Therefore, let's write x squared plus y squared equals r squared, centered at 0, 0, x minus h quantity squared plus y minus k quantity squared equals r squared, centered at h and k. Let's remind everybody the area is pi r squared and the circumference is 2 pi r. Therefore, when we have the radius equals 2 and the center is located at 1 minus 2, according to this formula, the equation becomes x minus 1 quantity squared plus y minus -2, which makes it plus 2 squared equals r2 squared or 4. So the center is located at 1, -2, so 1 to the right, 2 down. And now we look at the radius. Since the radius is 2, we add 2 units to this point going left and right as well as up and down. So left and right will give us the pairs -1, -2, 3, -2. Going back to the center up and down, we are going to, since r equals 2 units, we are going to add 2 units up and down, giving us 1, 0, 1, -4, and putting them all together gives us the following graph. So we have the equation x minus 1 quantity squared plus y plus 2 quantity squared equals 4, and we have the graph of the circle. Write the equation of a circle in standard form, meaning in this case, x minus h quantity squared plus y minus k quantity squared. Identify the center and the radius, graph the circle. So we are going to put the minus 4x next to x squared, 10y next to y squared, and move the -7 to the right, make it +7. Perfect square trinomial. This is b divided by 2. Becomes -2 squared, becomes 4, add 4 to both sides. This one is b, 10 divided by 2 is 5, squared is 25. So in this case is -4 divided by 2 squared. In this case 10 divided by 2 squared. So when we add them to both sides, the left side becomes x minus 2 squared plus y plus 5 squared. And the right side is 36 or r squared. Therefore, this circle is located at +2, -5, with the radius being squared of 36, which makes it 6. We put the center at 2, -5. This is the axis we have. So because the radius is 6, we're going to go 6 units to the right and left. We're going to go 6 units up and down. So right and left, that means this is the number that you deal with. Right, you add 6, left, you subtract. And up and down, that means you add to the y coordinate 6 units, and also you subtract it, so you get 2. When you add it, 2, 1. When you subtract it, 2 minus 11. And if you plot those two, now we are ready to put them all together. Here's your graph. What about an ellipse? We want to graph the ellipse by finding its center and vertices. X squared over 25 plus y squared over 16 equals 1. Number one, what is an ellipse? An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse, where PF1 and PF2 equals to A. So let's take a look at this. Let's plug in all of those. So if it's centered at 0, 0, if you pick any point on an ellipse and connect it to the two foci F1 and F2, PF1 and PF2 is fixed and it's equal to 2A. If you pick the point to be here, you see that these two are identical by symmetry, and it adds up to be 2A. If you pick this point, this distance, and then this distance, they add up to 2A. Also, the general form, when it's centered at 0, 0, we have x squared over a squared plus y squared over b squared equals 1. When it's centered at h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. And bear in mind that a circle is a special case of an ellipse. So the area is pi AB because if A equals to B, we have a circle, and it becomes pi r squared. Now, B squared plus C squared equals A squared. In this case, elongated along the x-axis, A is larger than B. May not be always the case. But A, B, C follow Pythagorean theorem. In this case, C is the focal distance, and it's definitely smaller than one of those two at least. So it's always on this side, but it could be B squared plus C squared equals A squared, as it is the case here, simply because B is smaller than A. It could be A squared plus C squared equals B squared if it's elongated along the y-axis and P is larger. So with that being the case, it is centered at 0, 0. A equals square root of 25, which is 5. B is square root of 16, which is 4, according to this formula. So we have the center, and then we go A units to the right, A units to the left. Those are the vertices. Then we go from the center B units up and down. They are called co-vertices. And we put them together, and that's an elliptical shape. Identify the coordinates of a center, the vertices, the co-vertices, and foci, graph the ellipse. So again, we have the general form here. The center of the ellipse is located at -5, +7. Take a look. A is square root of 4, which is 2. B is square root of 9, which is 3. Again, we are just comparing this to this formula. So we have the center at -5, 7, 5 to the left, 7 up. So we are interested in the vertices. Since B is larger, the vertices are along the y-axis, or in this case, parallel to that. So we are going to go B units from here, B units up. That means this becomes 10, B units down. That becomes 4, and those are the pairs. A, which means 2 units to the left and to the right. So to the left, -5 - 2 makes it 7. To the right, +2 makes it -3. And of course, the y coordinate is the same. Plot those pairs. Right now, we can graph it, but let us go over the foci. We want to see where they along, according to this formula, b squared plus c squared equals a squared. In this case, it's very important to understand that a is larger than b. Again, the relationship among a, b, c is a Pythagorean relationship, okay? But we have one of these two, and it depends which one is larger. Is a larger or is b larger? So when we look at this one, we see b is larger. Therefore, we're going to stick with this formula. So a squared plus c squared is b squared. C becomes square root of 5 because you already know a squared was 4, b squared was 9. We had it. So c squared is 9 minus 4 or 5. C is square root of 5. So from the center, go up by this much and go down by this much, because those are the vertices, and that would be the location of foci. So minus 5 remains the same. 7 minus square root of 5, and then 7 plus square root of 5. Now at this point, you plug it into a calculator. Roughly 4.77, and this one roughly 9.24. You plot those two pairs, and now that's the graph of the ellipse. Use the graph of the ellipse to determine the equation in standard form. And of course, here's the standard form. We are looking for h, k, a, b. So we locate the center, and we read it as negative 2, 2. So we locate the center. Then we locate the vertices and co-vertices, and we read. The vertices are located at negative 2, 5, negative 2, negative 1. So this distance is b. So from 2 to 5, we go 3 units up. Therefore, b is 3 over here. This distance is a. From the center to the left or right, there is a distance of 2 units. It's easy to read it from here. Therefore, a is 2. So a is 2, b is 3. Now we're going to plug in x minus h, that means x minus minus 2 or x plus 2, quantity squared, over a squared, that means over 4, plus y minus 2 quantity squared over b squared, that means over 9, equals 1. So we got the equation in standard form from the vertices, the center, the co-vertices. Give the equation of the asymptotes and graph the hyperbolas. A, x squared over 16 minus y squared over 25 is 1. B, y squared over 25 minus x squared over 16 is 1. Now, first and foremost, let's quickly go over the concept of a hyperbola, which looks like that. The equations are x squared over a squared minus y squared over b squared equals 1. If you are looking at the blue one, y squared over b squared minus x squared over a squared equals 1. If I graph it like so, so this one would be this one. When we write them in this fashion, we keep the b under y, and not all texts do that. Then the asymptote has the equation y equals plus minus b over a times x, and it remains unchanged. And no matter how you look at it, whether it opens sideways or up or down, always see the focal distance is the largest. Therefore, a squared plus b squared equals c squared. And here's the definition. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. Now, if you pick any point and connect them to the two foci, focus 1, focus 2, their difference is constant, which is 2a. And one easy way, if you pick this point and you look at this distance minus this distance, that gives you 2a. So center at 0, 0 for both cases. A square root of 16 or 4. B square root of 25 or 5. And so in this case, the vertices are 4, comma 0 minus 4, comma 0. So centered at 0, 0, A equals 4, B equals 5 again. Asymptotes plus minus B over A, 5 over 4x. That's the case for both, in fact. But in this case, the vertices are, since x squared has a positive value, x is 1 over 16, it's located at 4, 0 minus 4, 0. So this is the asymptotes for this one, 4, 0 minus 4, 0. Let's locate those. Again, this one is for the second one, and for the first one, looks like this. I wanted you to be exposed to both of them on the same page so you see the difference. Now, in this case, because y squared has a positive value, it opens up and down, and the vertices are located at 0, 5, okay, up here, and 0, negative 5. The graph looks like that, and those are always dashed lines. By the way, I want you to look at this, is known as fundamental rectangle. The purpose of that is if you locate those 4 points, you can draw the two asymptotes. And location is very simple. This one is located at A0. This one is located at 0B. Therefore, it's located at AB in general. A, comma B. So what would this one be? A, comma negative B. How about this one? Minus AB. And in this case, minus A, minus B. Again, if you locate those 4, you draw a rectangle, and then diagonals are the asymptotes. That's why it's called the fundamental rectangle. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptote. Graph the hyperbola. So, centered at 1, 2, A is square root of 9 or 3, B is square root of 16 or 4. It's the first thing we notice. Since we see a positive value here, this is negative, so this one, then it opens sideways. In essence, we have x squared, it opens sideways when it comes to this hyperbola. So from the center, we go A, that means 3 units to the right and left. We can draw asymptotes using the formula y minus k is plus minus b over a times x minus h. We can do that first. And so y minus 2 is plus minus b 4 over a 3x minus h, which is 1. And if you write down 4/3 x minus 4/3 and move the negative 2, by the way, this can be moved, and you end up with this equation. And if you go with plus 4/3, this is one equation. If you go with negative 4/3, there is another one. And this, you can easily see that we want the intercepts for the sake of graphing. So we have 0, 2/3, and if you set this one equal to 0, x becomes negative 2 over 4 or negative 1/2. So those are the two pairs to graph this x and y intercept. So this is the y intercept, this is the x intercept. If you use minus 4/3 here, you get minus 4/3 x plus 4/3 and 2, you end up with minus 4/3 x plus 10/3. And for this one, the two pairs are 0, 10/3. This is clear. And then if you set y equal to 0, then x becomes 10 over 4 or 5/2. This is for the sake of graphing the two lines, the asymptotes. So plot those two pairs, and you can graph it. It may be a little bit hard to see because of the scaling. So 0, 2/3 is here, minus 1/2, 0 is here, and that's the red line. And this one, 0, 10/3. 10/3 is like 3 and 1/3. That's why you see it's between 3 and 4. 5/2, this is 2. See, 5/2 is about 2.5. This is not too scale, but it's close enough. And so those are the two asymptotes. That's the center. And basically it opens this way and that way by finding vertices. So go back to the center, and a equals 3. So we're going to go from the center a units, 3 units to the right, which makes this one 4, 3 units to the left, which makes this one 1 minus 3 or negative 2. So 3 to the left, 3 to the right. Those are the vertices with coordinates negative 2, 2, 4, 2. You want to find the foci. A squared plus b squared is always c squared. This doesn't change because c is always greater than both of them. And so basically, this is a squared 9, b squared is 16. So that's 25, and c squared is 25, c becomes 5. I hope it's clear to everybody how we arrive at it. Now, this is the focal distance from the center. And since it's going to go this way, everybody, right? From the center, you go c units to the right. And from the center, you go c units to the left. You write F1 and F2 in essence, okay? Now, if I want to go to the right of this, I'm going to add 5 to that. I get 6, 2. If I want to go to the left of it, 1 minus 5 or negative 4, 2. Those are the points, right? And here's the graph. And I want to make sure that the two asymptotes are dashed lines because they are not part of the graph. They will help us see the graph, but they are not part of the graph. Use the graph of the hyperbola to determine its equation in standard form, and we can see that, for example, right here we have the grid, the axis has been moved in essence, so we're going to follow x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1, and try to find this. And the very first thing we notice, the center is located at minus 1, 0. And from there, we want to find a and b. Since it opens up, okay, we can see this distance. So from here to here, we can find the b since it opens up. And this is located at minus 1, 3. This is located at minus 1, minus 3. So this distance equal to this distance equals to b equals to 3. Clearly, 3 units. Now this is foci located at negative 1, 3 square root of 2. And this is another one located at negative 1 minus 3 square root of 2. And this distance is c. The distance from the center to focus 1, the distance from the center to focus 2, they are identical. And that would be c. So c units up and down give us these 2 points, right? From the center. We just go up by this much. So 3 square root of 2 must be the value of c. Now we know a squared plus b squared equals c squared, and c is the largest one always in the case of hyperbola. So what is a? We don't have it. What is b? 3 squared. What is c? 3 squared of 2. And so this is 9. I hope you see that this becomes 9 times 2. When you want to square this is 9, square this is 2. Their product is 18. And therefore, a squared is 9, a is 3. A squared is 9, a is 3. So now we are ready to write the equation as follows. Because it's up and down, y minus k quantity squared over b squared minus x minus h quantity squared over a squared. So y squared, and you look at the center, y squared over 9 minus x minus minus 1, that means x plus 1 quantity squared over 9 equals 1. By the way, why 9? Because a and b happen to be the same, is number 3. As far as the asymptotes are concerned, y minus k, which is 0, equals plus minus b over a, which is 3 over 3, x minus h, which makes it x plus 1. And as you can see, this 0 has no bearing, and this is 1. So there are 2 asymptotes, y equals x plus 1, y equals a minus x minus 1, and we are done. What is a parabola? Let's define that. A parabola is the collection of all points P in the plane that are the same distance d from a fixed point. If, as they are from a fixed line d, the point F is called the focus of the parabola, and the line d is its directrix. As a result, a parabola is the set of points P for which the distance between F, the focal point, the focus, and that point P is the same as the distance from that point P to the directrix. These 2 distances are identical. And for that, if you look at the center and look at the distance from here to the F and to the D, these two must be the same. And this is called focal distance. Sometimes they call it F, sometimes they call it P. Now we recall in algebra, intermediate algebra, y equals ax squared plus bx plus c. This opens up and it's in the form of a times x minus h quantity squared plus k. If it opens sideways to the left and right, it's second degree with respect to y, ay squared plus by plus c, and it's a times y minus k quantity squared plus h. This we already know. Now, we have a slightly different types of formulas. We don't have to memorize them because as long as we know the relationship between a and p, we are fine. Y squared is 4px, y squared is minus 4px. In this case, y is of degree 2, and this one opens to the left, this one opens to the right. All right, so we can write it in this format where P is the focal distance. As you look at this one, you notice, by the way, you can move the negative sign around. So this is quadratic with respect to y squared, so it opens sideways. This is quadratic with respect to x squared, it opens up and down, okay? So as you can see, and the moment you see a negative, it opens to the left or opens down. The relationship between this A, and sometimes even they call this one A. I want you to know that, but I like to use a different letter for that, either P or F. So this A and this P have the following relationship. P is 1 over 4A or A is 1 over 4P. This way, if you're familiar with this one, you know how to do it, you can go this route and then change it, it doesn't matter. The next thing that I want to mention is what's called latus rectum. The latus rectum of a conic section is the chord through a focus parallel to the conic section directrix, which is equal to 4P, meaning this distance from here to here. So if we draw a parallel line to the directrix, this is equal to 4 times the focal distance. Why is that? It's very simple. This is P, so is this one. I hope you see this distance from here to here is P, just by definition. This distance is P. So with this one, there are two of them, and the distance from here to here is also 2P. So this point, if you connect it to F or directrix, they must be the same. Therefore, this distance is the same as 2P. Since we have two of them, this is 2P, this is 2P, they add up to 4P. So y squared equals 4px, y minus k quantity squared is 4p times x minus h. X equals a times y minus k quantity squared plus h, and what matters, a is 1 over 4p. So you don't have to memorize anything new. As long as you remember the intermediate algebra, you're in good shape. We're going to look at this one, and we have the formulas. Identify the coordinates of the vertex, the focus, the length of the latus rectum, and the equation of the axis of symmetry, and the directrix, graph the parabola. So let's first and foremost draw the vertices located at -4 and +2. And the reason we know it opens to the right, this is a quadratic with respect to y, so it opens either to the right or left. And because it has a positive value, okay, you don't see a negative one, so it looks like this in essence, if you will. We know it opens to the right. So what I want you to notice is that the vertex is located at this point. So if I were to graph it roughly, and again, I just want to show you something. The graph looks, and this is not good, but the graph looks like this. So somewhere inside is the focus. Somewhere here is the directrix. Do you follow what I'm saying? Meaning, since I have this location, -422, in order for me to find this location for the focal distance, all I have to do, calculate the P, and then add this to find out what the X coordinate of the focal point is. So I'm going to go to the right by P units. That's why you don't want to really memorize all those numbers that they give you. You want to understand how that works. On the other hand, if I want to find the equation of a directrix from the center, from the vertex, I want to go to the left by P units. Okay, so, and then I find that, and the vertical line has the equation X equals whatever that number is minus P in essence. So that's what we're looking for. Okay, so let me erase that. 4P is 4/5 according to the formula here. 4P is 4/5. P is 1/5 or 0.2. So this distance is 0.2 or 1/5. Therefore, the focus is located at this point, move it to the right by this much. So add 1/5 or add 0.2 and you get negative 3.8. Okay, just a little bit to the right. I want the axis of symmetry. The axis of symmetry is just this line, y equals 2. I want the directrix, and I said, you know, from the vertex, I got to go to the left of it by this much, p or 0.2. So -4 minus 1/5 or minus 0.2. Therefore, x equals -4.2 is the equation of a directrix. So this is the axis of symmetry, and this is the directrix. And that's the graph. Now, latus rectum is this distance, and it's 4 times P. And 4 times P, we already know is 450. So the latus rectum of a conic section is the chord through a focus parallel to the conic section directrix, and we know it to be 450. So we have all the questions answered. So the best course of action is you have a rough sketch before you calculate the location of everything else. It makes it a tad easier to see that this one is to the right, directrix is to the left of the vertex, and it makes life easy. We want to use the graph to determine the equation in standard form, and I want to quickly go over that 2 different ways. So first and foremost, if you want to go this route, we notice that it opens down. That means x must have degree 2. If it opens up or down, x must have degree 2. So therefore, we are going to go with x squared equals 4py, or x minus h squared is minus 4p times y minus k. I want to show you both ways. The very first thing, the vertex is located at -3, 5. And the focus is located at -3, 319/64. So if we go with this one, x minus -3, that means x plus 3 quantity squared, minus 4 times the p, y minus k, that means y minus 5, and I want to discuss the p. P is the focal distance, which is this distance, everybody. Let me draw. Focal distance is this distance. The distance from the focus to the vertex, this much. So all we have to do, say 5 minus 319 divided by 64, and that ends up being 1 over 64. So now plug everything in. These two, they give us negative 1 over 16. Or we can go with this method. I want to show you something. And say y is a times x plus 3 squared plus 5, because we have the vertex located at negative 3 comma 5. We know the relationship between a and p. A is 1 over 4p if it happens to open up or open to the right. Otherwise, the relationship is that, a becomes negative. Remember, this opens down. A must be negative. So a is 1 over minus 4p. So minus 4 times 1 over 64, and then flips over, becomes negative 16, and we say y is minus 16 times x plus 3 squared plus 5. So whatever route you take is fine, but you should be able to distinguish between the two methods and figure out the relationship between A and P. That's all you need. So if you look at this one, if you move things around, if you move the 5 to this side, everybody becomes y minus 5. If you divide by negative 16, you get this one. I hope you see that you can go from here to here easily. Move the 5, divide by negative 16. They are the same. And the reason I mention it, because if you have learned this and you have a hard time memorizing this, stick with that, and then all you need to know the relationship between A and the focal distance, P or F they call it. Given the function, express it in standard form, A times x minus h quantity squared plus k, and find the x-intercept, the y-intercept, the vertex, and the axis of symmetry, and graph it. So for this one, first, let's put these two together, and we're going to factor out the two. So, by the way, this is the standard form we have learned in algebra, intermediate algebra, 2 times x squared plus 2x, and we put the 6 to the side. Now, we want to complete the square, which means b is 2, divided by 2 is 1, and if you square it, you get 1. So we're going to add 1 inside the parentheses. If I add 1 in here, that means I'm adding 2 times 1. So either I add 2 to this side or subtract it from the same side. Please understand, I'm adding 1. That means I'm adding 2 plus 1. I can say I'm going to add 2 to this side, 2 to this side, 2, or I'm adding 2, I'm subtracting 2. And therefore, I end up with 2 times x plus 1 quantity squared, and the 2 add up to 4. Therefore, I have the vertex of negative 1 comma 4. And I know it opens up because A is 2 and it's positive. So opens up because A is 2 and it's positive. So that's the vertex. We don't have any x-intercepts, and the y-intercept is located at 0, 6. Clearly 0, 6, that's the y-intercept. But why is it that we don't have any x-intercepts? You can set this equal to 0, and it doesn't give you any answer because, let me just remind you, if you set this one equal to 0, you can calculate b squared minus 4ac, and that is a negative value because it's 4 squared minus a 4 times a, which is 2, times c, which is 6. And since it's negative, it has no real solutions, right? It has two complex solutions, imaginary solutions. So they don't correspond to an answer. So no real solutions. Let's go with the axis of symmetry happens here, x equals 1, negative 1. And by the axis of symmetry, because this distance is 2 units, if we go 2 units to the, this distance is 1 unit. If we go 1 unit to the other side, there is a point here with coordinates negative 2, 6. Okay, and now it opens up, we can graph it. So it's easy to do it that way. We want to identify the graph in each case, and I want to go over a couple of things to make sure everybody understands what's going on. So if you know you're dealing with conic sections, when x squared and y squared have the same identical coefficients, it's a circle. Of course, you can put it in standard form and prove it. So, but at a glance, they are identical. This is it. These two have the same sign, but they are different. Both of them are positive, but they are different. It's an ellipse. You can prove that. This one, you bring it to the same sign. Since x squared and y squared have coefficients that have different signs, opposites, it's a hyperbola. Circle, ellipse, hyperbola. And you can prove that. How? Put them in standard form. Determine whether the graph opens up, down, left, or right. This one, quadratic with respect to, remember h of x is 1, quadratic with respect to x. So it either opens up or down. The reason it opens down because a is negative 2 and it's negative. Because of this opens up or down, because a is negative, it's down. Quadratic with respect to x, again, opens up or down. The coefficient is positive, it opens up. Quadratic with respect to y, therefore it opens either to the right or to the left. Because the coefficient is positive, it opens to the right.